Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We're in the bonus lessons and we're actually in week 65. And in this lesson, I'm going to continue our discussion of the Java programming language. And in this particular lesson, we are going to look at doing something actually for real with Java, not just a little example teaching program. So what we're going to do is we're going to replace the host monitor functionality that gives us all of this cool host data in terms of the tables and in terms of response time and availability, etc. We're going to replace that with a Java version. And so we're going to see how easy it is to do that in terms of integration. We've loosely coupled all of these components via this RESTful API. That means that I can have coexisting different applications running in different programming languages, etc., and it has no bearing on any of the others as long as I'm adhering to the RESTful API and providing the information as I'm supposed to be doing. So that is the general idea of what we're doing. We will be looking at code. So we're going to be looking at the structure of the code. We're going to be looking at the code itself. We'll have a bunch of these classes, a main class, a monitoring class that we create, a discovery class, which is also a thread. And of course, we need to store the data somewhere. So we have this class called host in which we store all of that wonderful data. Lastly, we'll talk about how easy it is to run things from the IDE, but it's more difficult when you try to run it from the terminal. And so I'll show you how I did that and some of the extra stuff you have to do to run a Java program that includes functionality from external libraries. Anyway, that's what we're going to talk about. So let's get started. So we've seen the implementation of that first Python method, that device program that we looked at before, that basically is a very simple, in Python it would be a dictionary, in Java it would be a hash map, implementing that and printing it out and even having a for loop. So we've seen that. That's pretty simple and straightforward, even though the syntax may look a lot more confusing than Python. That's not going to be a surprise when you get used to Java code. But let's look at an implementation that is actually doing something like a real world thing. And for that purpose, we're going to implement the host monitoring application from quokka-prime. And we are going to do it in Java. So let's look at this picture and understand a couple of things here. This picture you've seen before, or a form of it. This is exactly what it looked like before, except for this green thing in here, which used to be just the regular host monitor, and I have expanded it so I could fit the words in there. It is the host monitor that is implemented in Java. And you may say to yourself, whoa, can you do that? You're holding your head like I am right now. Of course, you can't see me doing that, so that's kind of silly, but you're saying, how can you do that? This is a Python application. And the way that we can do that is because of the way that we have designed this quokka-prime application. Now, I did not design the original Quokka application this way. If you'll recall, I implemented all of these monitors, etc., as threads within the Flask server for the original Quokka. But for quokka-prime, which is what this is, I have implemented things differently. I've implemented these for teaching purposes as separate applications, and I have decided that maybe there are some significant advantages to this in terms of doing remote monitoring of devices and services and hosts, etc. And so we've talked about that. One of the other advantages of doing it this way is that I can theoretically implement host scan, device monitor, service monitor. All of these things can be implemented in any language that I choose. In fact, I can import other applications from elsewhere and use them provided they adhere to basically this RESTful API. So this design pattern or this design style, we used to call it loosely coupled. And in fact, if you go to Wikipedia, there's actually an entry that talks about loose coupling in computer science, and it's got a lot of computer sciencey stuff in here, but let me explain it to you in general what we mean. What we mean is, rather than this application being part of something else and an internal class, say, of this Flask application, our Flask application, instead of doing it that way, it's an independent, autonomous application that I just run from the command line. And you can see I'm actually running it from the command line here. This is my Java code. And so why can we do this loose coupling? We can do it because the way that it communicates with the rest of the application is through this RESTful API. So we can put hosts into the database. That will cause status to get recorded. It will cause status summaries to get generated. This application doesn't have to know anything about that. It doesn't know that this is Flask. It could be a Java web application. It could be Ruby. It could be Go. It could be any other type of web service that we wanted to do. This backend database could be Mongo. It could be Postgres for SQL. We've talked about that before, and you've gotten this idea. I just want to re-emphasize the importance of using your brains to design an application in an intelligent manner. And of course, there are trade-offs. If these were running inside this Flask server, it would be a little bit quicker. It would cause less overhead in terms of HTTP requests. On the other hand, the benefits are I was able to create this thing in Java and have it seamlessly, almost seamlessly, integrate directly into the existing application. And if we look here, here's my Quokka application. Here are my devices. Here are my services. I'm able to do everything as I was before. And guess what? Here are the hosts that it has discovered. Can I look at any of this information for my host? Yes, I can. Why does my availability look funny? Because I just started it in the last 10 minutes. But in a certain amount of time, we will have this line going up and down and up and down and up and down. This line over here, I have been running it over time, so you can see that I have data, and that is still valid. The fact that I swapped out a Python implementation of this host monitor with a Java implementation had almost no bearing whatsoever on all of that data. In fact, it did have no bearing. If you're eagle-eyed, you will have noticed something is a little bit different, and I'll talk about that in a minute, and that is we don't have the MAC address. And that is a circumstance of the way that I implemented it in a kind of a cheaper and easier and quicker and simpler way, so we don't have the MAC address, and I'll talk about that when we look at the code. But I want to impress on this on you one more time, and that is this: because of the way that we've designed it, going forward in the future, it makes it very easy for me to replace these other applications should I desire to, because of the fact that it's just loosely coupled. It's that REST API, and frankly, any application can do a REST API. So that's the overview. Let's now look at the code. Okay, so let's look at the code. The first thing that I want us to do is just understand where I put this code. Now you can kind of see this. I'll try to remember to zoom in, but over to the right here, you can see that the actual location of my Java project that I've created in IntelliJ, my free version, community version of IntelliJ, is in the quokka-prime directory. In fact, it's quokka-prime /monitors/Java. Java is the folder in which this lives. I did that so that you will be able to get that from the repository. So it's not in a separate repository, it's in the monitors folder, and it's just denoted /Java. It's in that folder so that you can find it there. Now the second thing that you'll notice is that there's a fair amount of hierarchy or structure related to where everything is. Remember, in Python, everything just kind of lives within a folder, and everything that I create is a folder with particular meaning. And what we have with Java is this: when you get into doing Java stuff, you're going to have some type of build tool that you will use. And the one that I've used most often, most recently, is called Maven. And Maven, you will understand what they do is they one of their phrases or things that tells people what's going on is they favor convention over configuration. And the general idea there is this: in the olden days, when we would build C and C++ and even before that languages code in Java before this, we would have to create build scripts that said where the source code was, where the output was going to go, etc. What Maven did, Maven is one of these build tools that helps pull in dependencies similar to what when you do pip install in a Python world, it installs stuff and you can just run it. It's more difficult in the Java world, and so we need to specify dependencies, such as dependencies on stuff that will do JSON for us, things of that nature. And so Maven will help us out with that. And Maven wants everything to be organized in a particular way. This is a long way of saying that's why there's all of this stuff here, okay? Don't be freaked out by it. It's just my code is going to be in source. It's a little bit like the UI code where when we looked at React, it put everything in a folder called SRC. There was a whole bunch of stuff elsewhere and things going on, and we didn't worry about that. It's pretty similar here. I just created a project, and I had to give it a name, so I called it Quokka Home. And then here's all of my software. These are the classes that I created to do the Java stuff. So that, in hopefully a semi-understandable nutshell, is why this layout of all of these folders and package names and stuff like that is the way that it is. Okay, let's start looking at the actual code. So we're looking at the main application class for our host monitoring application. It's called main. As you recall from the example that we did last week, we are going to need to have something, a method defined that's going to be called something like this in order for it to run. So when we run Java and we point it at our class that has been compiled, it will be looking for this, and this is what it will run. That's the first thing to notice. Public, let me just go over these really quickly. Public means anybody can access this. Static means that this isn't a class that is going to get instantiated into an object. It is a static class, and so basically you just call functions within it. You don't create the object, and it doesn't have its own data that lives with it. So that's kind of what static is. Void, that's the return value. There will be no return value. Main is the name. The stuff in parentheses here, this is special because it's intended to be run from the command line. This is where my command line arguments will be, and if I had chosen to do so, as I have in many of our Python applications that we've seen, then I would want to have them implemented here. In this situation, I'm doing fairly bare bones discovery of hosts and monitoring of hosts, and so I'm not doing anything with them. Remember, we're using curly braces. Indents don't matter. These could all be starting at location 0 without any indentation, or it could all be on the same line, because the compiler is smart enough to look at these open and close curly braces and know where things begin and end. There's two things going on here. The first thing, as you can kind of tell, that's discovery stuff. The second thing that's going on is monitor stuff. And so just looking at this really quick, you can see I'm doing some thread type stuff here. I'm actually going to be creating this thread and then starting it. That's because discovery There's nothing like Scapy, which goes out and very quickly, within 30 seconds or so, discovers all of the hosts on the network along with some information about them. We're going to need to do it on our own by pinging every device. As you can imagine, that's a lot of wait time because we're not doing it in a multi-threaded or an asynchronous manner. I'm trying to keep it simple. So I created a separate thread in which to do discovery. So it's going to be out there percolating on its own thread, and we will look at that in a minute. And similar to what we do in Python, in order to start my thread, I'm going to call the start method, and that will begin to run my thread. As I say, I'm doing everything as simple as possible for learnability purposes. Is that a word, learnability? It is now. So yeah, learnability purposes, making it easy to learn. That's what we're doing there. Now, the second piece of code here is the monitoring code. And so this is going to be a class called monitor. I'm going to instantiate an object from that. Now, notice here I need to declare what type of object this is going to be. So remember, we do static typing. In Python, we would have left this blank. And of course, if we do this in Java, it's going to complain about that. Now, let me tell you one thing that has been done recently in Java to make our lives easier, and this is somewhat similar to the way that things are done in JavaScript. I'm not sure who started this, but if I use the var keyword, then what happens is the Java compiler is smart enough to infer what the type of this object will be. And I'll show you this in other situations where the PyCharm will actually put into my code something that tells me what type of thing this is. But let me go back to the way that it was, just so that we're more explicit there. There's nothing wrong with doing this. So I'm going to create this monitor, which is going to be an object from the class capital M monitor. And then I'm going to call a method within it called monitor hosts. And as you can imagine, just by looking at this is going to spin forever, monitoring hosts, until I do a Control C. Also, as you can imagine, when I start this discovery thread, it's going to start discovering, and it's going to continue discovering until I do a Control C and stop it. And so this is what it looks like when it's running. I just did a Control C. You can see it stopped. It doesn't give ugly stack traces or anything. So, and this is what my running it looks like. So I'm running my actual program. So that is the main class. And now let's look at some of this other code that actually does something. Okay, let's look a little bit deeper at these things. First, let's look at this discovery thread. So discovery thread is a class that we define. Notice that it extends thread. That means that we are a subclass of thread. So all the nice stuff that a thread provides, we get for free. And that's going to mean that certain things will be true, like we can be started and our application will run on a separate thread, of course. So let's take a look at a high level first. This is the constructor. Remember, like in Python with underscore, underscore, init, underscore, underscore, underscore. That's what this is. And we don't do anything in here except print out that our discovery thread has been created. We're going to have a member variable here that's a Boolean called terminate. Now, in this particular application, I removed stuff related to terminate because it just made things confusing, and we're only having a couple of short amounts of time to look at this code anyway, so we're not going to be going into that, but that is the terminate, similar to what we had with our Python threads that we ran. So at a high level, we're going to have a method. It's going to be internal. Private is where we get to say only things inside this object are going to be able to call it. So that's what private means. Public means anybody can call it. I'm going to have something called discover hosts in here, and we'll look at that in more detail in a minute. Here's run. This is what gets called when in main, we invoke this method called start. That's a thread method. And you can see there that it's telling me that it's a method that's within thread. We could actually go look at that if we wanted to, but we're not going to. We're just going to look at the actual code and see what it does. And in fact, it doesn't do a whole lot. Basically, this is the code that it does. Everything else either is window dressing for printing out what's going on, or it's doing wait time stuff. So don't worry about all of this stuff. It's just me waiting for a certain amount of time. And this is what we're going to do. While not terminate, we're going to discover hosts, and then we're going to wait. And this is going to be waiting for 60 minutes. So we only discover every 60 minutes. Remember, this isn't monitoring, this is discovery. So discover hosts is the important thing. It is defined here. As we talked about, we zipped through it. Let's take a look at what it does. And there's probably more here than I have time to go into, so we're going to go over it pretty fast. But I do just want to give you a general idea of what it's doing, and you'll see that it's not very difficult to stuff that we've done before. Discover host has no parameters. We are going to have something called an inet address. Now in Java, as I mentioned, things don't come for free, so I have to declare java.net.inet address if I'm going to use it. And I do that, inet address localhost. Notice this, here's an important thing that you need to be aware of, and that is the word scope. Java has very more precise rules related to scope. In other words, if I declared inet address host in here, then it would only live, this local host would only live within these curly braces, and I would not be able to reference it elsewhere. So by defining it here, I'm able to use it within the beginning and ending curly braces. So be aware of that. That is my local host. This is a Java class that gives me a fair amount of functionality, and including the ability to call get localhost, and that will give me an inet address object that is going to have all localhost information related to it. Now we have try except in Python. Here we have try catch. It's basically the same thing. We're looking for exceptions, and in this situation, if I can't get my own localhost inet address, then I'm going to say, you know what, I can't do this, so it's going to just return. And we hope that won't happen. I don't know that that's ever happened. Anyway, here's my localhost. Another thing I can do is I can say get address, and my address is actually going to be a byte array. This syntax here says byte. That's a primitive data type within Java, and these square brackets here identify the fact that this is going to be an array of bytes. And now what I'm going to do, now that I have my own local address, I'm going to come through and I'm going to iterate through, and you might guess what's going to happen here. I'm going to have my for loop, which starts with the first value of I is going to be 1, the numerical value 1. It's going to continue while I is less than or equal to 254. And at the end, it's going to increment I. So at the very end of this loop, of this for loop, which is down here, the last thing it will do is increment I. And you might think, I bet I know what you're going to do, and you're right. I'm going to be patching the last byte of my IP address with that numerical value. And that's what my address is. And now I'm going to go and I'm going to use this class, this inet address class, and I'm going to say get me an inet address based on this IP, and it wants a 4-byte IP address, so 4 numbers in this array that we created here, and that's what I'm passing in. And now at this point I will have an address, an IP address. And from that IP address, here's the most important thing. Basically all I really need to do, I can take that IP address. Remember my scoping rules, I needed to define it or declare it out here, not inside here. So you may, if you're not familiar with this type of static typing, you may get bit by this a few times. Just remember scoping rules are important. If I had said inet address right here like this, then this thing called address would have only been accessible inside these curly braces, and that's why I don't do that. All right, so now we have that address, and the good news is it's very easy for me to try to ping that address. All I need to do is call on my address. Remember, address is an inet address. All I need to do is call is reachable, and I'm passing in this value here, and if it's successful, then I know that there's a host there, and if it's unsuccessful, then I know that the host is not responding. So remember, in quokka-prime, I used arpping, which was very handy and gave me a lot of information and did it fast. In the original Quokka implementation, if you have gone and looked at that code, I did this ping trick. It's not really a trick, but I used the ping method in order to do it. And that's what I'm having to do right here. And here I specify my timeout. You will notice, hopefully you can see this, this grayed out thing that says timeout, that is basically telling me what is the actual value there. And so that is not actually anything that I have written. So if I were to come in here and delete this, you would see that my timeout value has actually gone away. And if I come in here and say 3000, then PyCharm is popping in that actual type. So it's just a helper for me to do that. Now, once I have done this, then what I want to do, remember what I'm going to be doing here. Let me make this a little bit bigger. What I'm going to be doing here is I am going to be telling, let me go back to this, when I have the information about a host that I've discovered, I need to call this REST API to tell our quokka-prime that I've discovered a device. And so what I'm going to do is I'm going to create a host. What is a host? It is something that I have defined that should look fairly familiar to you. I've got strings for host name, IP address, MAC address, availability, response time, last heard, and open TCP ports. The good news is that will, if you've been following along, you'll know that these are the fields that I use when we create what actually eventually gets stored in the database, which is this information right here. And so I need to have a class to hold that. That's how we are doing things. And this is what I'm actually doing. And so I come back to my discovery thread. I'm going to create an object called host from the host class. And I'm going to say host.hostname equals the get hostname, host.ip address, availability is true. I'm going to calculate my response time based on how long it took. I'm going to do date, and then I'm going to go through and I need to create a simple date format, which is what I'm going to do. And then I'm going to actually cause that to be a string, and this will do my string in this pattern. This pattern is years, months, days, hours, minutes, seconds, and milliseconds. So that is what actually is getting stored in last heard. And the next thing I'm going to do is I'm going to call update host. You can imagine what that does, but we'll look at it in just a second. And then I print out that I discovered something. So that is my discovery process. Next, we will look at this update host. Okay, so let's look at what update host does. First, let's stay here for a second. Here I'm referencing util. Util, as you can see, is a file with a class definition that I have created. Now, the way that I'm using it in a static manner. In other words, I'm not instantiating this particular class into an object so that I have an instance, but rather I'm just referencing an actual method within it. Now, this is the way that you do things where in Python we might have just had a module, a Python file with a function in it, and we've done that in our code before. In this situation, because you don't have these freestanding functions sitting around doing whatever and getting called, instead they need to be part of a class definition, and so that's util is where we've put this. So let's dive down and take a look at this. Here I am in my util file, util.java, update host. Let's see what it does. The first thing to look at here, object mapper. This is something that is going to cause me a lot of headaches because not in terms of the code that I write, but in running it, because this is going to pull in a bunch of open source software for mapping Java class objects into JSON and back. And so that's what we are going to need to be using it for. I'm going to have a string called JSON host. As you might imagine, that's going to be a string that holds the JSON version of the host that I'm passing in. Remember, I'm passing in the host that I've just created. So I created this host, and now I'm passing it into update host. So let's look at what it does. The first thing I'm going to do is I'm going to use this mapper that I've created, this object mapper, and I'm calling a method called writeValueAsString, and I'm passing in my host object. And all you need to really know is that that's going to return a string that is going to be in JSON format. And if there's an exception for whatever reason, I'm going to print it out, and we're not going to update the host because we can't do that. Now, assuming that that's successful, this is the process that I'm going to go through in order to actually do my HTTP request. Remember, I am doing this. I'm performing this function, calling the REST API in order to update the Quokka database, etc., with the information that I have discovered. And so this is what the process I'll go through. Now you can see I'm using var in this situation. This is just the example where I could have said HTTP client, so capital H and capital C, HTTP client here, but I'm using this new functionality where I just say var. I do need to say var so that the Java compiler knows that I'm creating something, but it's smart enough to realize, what you're creating is this HTTP client thing, and therefore I know that this var needs to be and will be of type HTTP client. And so that is what magically happens, and it's nicely printed in here. That's not actually in the code that I wrote. Just be aware of that. It's grayed out. It's been put in there by, I was going to say PyCharm for a minute. It's been put in there by IntelliJ. The same is true for the URL. It knows that this is going to be a string, and my string is going to have localhost, host equals hostname. This should look familiar to what we've done in Python. So basically it's the URL string that will be used. And now the next thing that we do is we're going to do a put request. There are many different libraries that you can use in order to do HTTP requests. One of the newer ones, and one that seems to be the most popular, is this HTTP library that's part, as you can see, of java.net.http. So I'm using HTTP client, HTTP request, and HTTP response. Those are the objects, the classes that I will be using. So I do HTTP request. Again, I'm not myself creating this, but it is going to do it by, I call the method new builder, and it creates it using this URI.create, and I'm passing the URL in. Technically, my thing that I call a URL, I'm using the vernacular. It's actually going to create a URI for me. If you care about the difference, then you could change this in the code if you wanted to, but I just kind of use the sloppy way of saying URL. Now you notice I don't have a semicolon here. That's because I'm going to do some method chaining, and I'm going to actually, on top of this request that I'm creating, so I'm creating this request, and then I'm doing dot. I'm setting the header equal to this right here. And what I'm passing in is header values. The key is content type, and the value or the name is content type. The value is application JSON. That's because I am passing in JSON information to it. And the next thing I need to do is I am telling it that, hey, we're doing a put. I haven't told it that my HTTP request is a put. So I'm saying, hey, what I'm doing is a put, and this is the way I'm going to put my JSON string and have it become part of my HTTP request. And the last thing that I'm doing at the end of this is build. So it's going to build this entire thing. And so my thing that I called my name, that is, I called it put. I could have called it request. It doesn't know that it's a put until I put this on the end of it. But I'm creating this request right here. This is my one statement. That's on the right-hand side of this equal sign. Once I've done that, now I can come in and use my client. Remember, I created my client up here. I'm going to use my client, and I'm going to do send. And what am I sending? I'm sending in this HTTP request, which I've called put request. And then sending this in, I'm also letting the send functionality know that it is going to be containing this JSON data that I have included. So I'm passing in this handler so that it can handle the string of JSON data that I've given it. That's just how they've designed this HTTP client functionality and the HTTP functionality. And what I get back from that is a response. Notice I've declared the response up here. So this is an HTTP response. I'm going to use the handy method in response called status code to check to see if it's 2004, because I know exactly it needs to be 2004. If it is, I know that it was successful. If not, if something was wrong, like the server was down or something, it prints it out. And then in both of these situations, in all these situations, I return, because this is just my functionality to update the host. And that got called from here. And lastly, why is it in util? Well, the reason it is in util is because it's also going to get called from monitor. So you'll see in monitor, once I ping the host somewhere down here, I'm going to do my update host. So that's why it lives in util. And that is the util, the HTTP portion of discovery that we're also using for monitor. Next, we'll look at how monitoring works. Okay, so the last thing to look at here is the monitor class. Now remember, we started our discovery on a separate thread, so it can go out and operate on its own and wait for devices or IP addresses that don't respond, and this is entirely independent. It's running on the main thread, though I didn't create a separate thread for it. It is running on the main thread, and that's perfectly okay. So let's take a look at what monitor is all about. So here it is. Here's my public class monitor. You'll notice I'm not inheriting from anything. It's my own class. You'll also notice I don't have a constructor. That's perfectly okay. You use a constructor if you need one. Otherwise, you don't have to do it. Let's look at a high level. You can see I'm doing get hosts. And also by just perusing this really quickly, you'll see, oh, that's where you're going out to the REST API and getting all the hosts from the database. That's just like what the other applications do. In fact, this models very much what I did with Python in my monitor hosts, or host monitor. I can't remember what I called it in Python. So get hosts is going to get me all of those hosts, and that's a lot of code, but it involves unwrapping all of the JSON data that I get back. Ping host is what I'm going to be doing when I'm actually doing a ping of a specific host. Here's my host object that we created. It's got all the information about the IP address, host name, etc. Ping hosts, this is plural. Notice this one is just for a single host up here. This is ping hosts. I don't know why I didn't put those together. Probably could have just put my ping host functionality right here. But if you do that, I kind of wanted this to stand out. What is my ping host doing? I'm pinging my one host and then I'm updating that one host. So I do these one at a time and do both the ping and then the update. And here is my monitor host code. Remember what our main application did is it created this object called monitor and then it called the method called monitor hosts. And if I do control B here, it's going to take me exactly to where we were, which is this method called monitor hosts. And here you can see I don't have any terminate or anything going on. I decided not to implement that, I guess. And here is my while loop. It's a while true loop. All I do is I go through and I'm going to first get all of the hosts. So now I'm going to get these hosts. Now, I do get hosts. Here you'll notice I said var hosts, and look at what PyCharm is smart enough to tell me. It's telling me that what I'm going to get back is going to be a hash map, which the key is a string and the value is an actual host. And if you recall, you may or may not recall this. I do because I wrote the code and I dealt with it all the time. The way that I implement host in quokka-prime is we're not getting an array back. You would think that we would get an array of just hosts, but the way that I implemented it was as a dictionary in Python, which is going to be a hash map in Java, and the key is going to be a string. That string is actually going to be the host name, and that's just what we get back. Now, I, as a user of this interface, I don't have the ability, I mean, I could because I wrote all of it, but in a real world situation, it's not my domain or my right to say, I want you to change what you're doing here to make my life easier. I can make that recommendation and it may or may not get implemented, but I'm dealing with it the way that it works for all of the other stuff, which includes, remember, the user interface is also calling this. So my Quokka is calling this. My original host monitor is calling this. If I look at this picture right here, host scan is also reading all of my hosts. So there's a lot of people who are dependent on this. If I were to change my implementation here, it would have effects on everybody else. We probably don't want to do that. So yeah, anyway, it's not a big deal. I get a hash map back. The next thing I'm going to do is I'm going to iterate through all of my hosts. Guess what? This may look familiar. This almost looks Python-like. That's exactly what the method that I called in Python when I had a dictionary. If you call .values, it gets you just a list in Python, an array in my situation here with Java of the actual values. So those will be all of the hosts. And I'm going to go through them and then I'm going to print out that I got them, and that's good. Now the next thing I'm going to do is I'm going to come and I'm going to ping my host by calling ping hosts. And what am I passing in? Well, so let's parse this really quickly. I want to pass in host.values, which is actually going to be an array list. And so what I'm saying is I want you to create a new object. And this object is going to be an array list. And then the actual items in the list are going to come from this thing called hosts.values. Hosts, remember, is what I got back from get hosts. So that's what my hosts are. And this is what I'm going to call when I say ping hosts. So when I come to ping hosts, of course, I've defined what this is. So, this is one of the things with Java that's different from Python, and we've mentioned it multiple times, and you've seen it multiple times, but just so you know, I'm passing in hosts. If this was if this was Python, we would just have hosts here, and we wouldn't even try to statically define what the type is, but we're actually causing it to be very careful about what it accepts. And in Python, you can end up having many errors where what you're passing in isn't actually what you thought it was, and it throws your little stack trace exception. In this situation, we during the compile time, we enforce that this is going to be correct, and then of course that helps us to ensure that our code is correct. So here's my for loop. My for loop, can't recall how much detail we went into. We didn't go into a lot of detail. This is actually quite handy and simple. It's better than it used to be in earlier days of Java. But in order for me to iterate through this thing called hosts, all I need to do is use this type of for loop. And what I'm going to be doing here, I need to specify my data type. I suspect I could say var here, but I'm not sure. Here's my variable name, host. And then what I'm going to do is I'm going to ping host, and then I'm going to update host. So I'm going to actually do a ping host that will update the host object, and then I'm going to do an update that will update my host object locally, and then I'm going to call update host, which is going to do the rest call. So let's look at ping host. We know what update host is going to do. Let's see what ping host does. So here's my friend inet address. So this is how I'm doing stuff in the world of Java. It's a little bit similar to what we have in the Python world, where I'm just going to be saying get by name, and I'm going to pass in the host name. So my host.hostname is the thing that I'm going to use, and this will give me an inet address, which I'm then going to use by doing is reachable. Same thing that I did before with my discovery. I'm using this same method, is reachable, with the same timeout. I'd probably want that to be a constant somewhere in a production environment, but for now, just doing 3000 is probably okay. And if it works, then I'm going to say, okay, I'll get the response time. I'm going to create my last heard. And so yeah, availability, I said availability and response time. That's all I'm interested in doing. And last heard. And then what I will end up, I don't do anything except return from this. So when my ping host is done, then I'm going to do update host. And if it failed, my availability will be false, whether that was the IO exception or it just didn't succeed. This is reachable, gave me a false. Either way, I'm going to set availability to false. I won't update last heard, and I won't update the response time because I don't know those values. And then as we mentioned, we will call update host. So pretty simple what it's doing. This monitor host thing gets called, it goes through this and does this while loop forever, and then at the very end, of course, it's going to wait until in this situation it's going to sleep for 60 seconds, and then it's going to come back. This is the way that you can do a sleep that is the approved way of doing it in Java these days. And here I'm specifying this is a sleep of seconds. If you'll notice in my discovery thread, my sleep, if I can find my sleep, is minutes. So I'm sleeping, I'm sleeping for 1 minute here. I'm sleeping for 1 minute, but then I come back and I do my wait minutes. So I wait till I've done 60 of these. The reason for that is so that with that terminate, it could terminate gracefully, as I've done in Python. But I've seen that Control-C just does kind of terminate it in a decent manner without throwing exceptions, so I didn't have to implement that. So theoretically, I could have just done this thing right here with sleep as 60 and gotten rid of everything else. In fact, why don't I just do that for us right here? So now I've changed that. What I'm going to do is I'm going to come and I'm going to delete this, and I'm going to delete this, try an exception, and this. And so here I am, and I must have messed up. I need the exception. So yeah, let me put the exception back. this is what I needed to do, and I need to get rid of discover wait minutes. And you'll notice that, let's see, let me get rid of this too, because I don't need that. And I still have an error. What's my error? My error is right here. So you've seen some real-time getting rid of me doing some debugging. So now what you'll notice, I just want to point this out. Sorry for the delay and for taking so long, like up to a minute. Hopefully it wasn't too bad. You probably noticed this before I did. But it says no problems are found, and you look at this and you say, wait a minute, that just looks wrong. And the answer is, remember, Java does not care about indentation. What we would probably end up doing is something like this, do a shift tab, and now it actually looks like it's supposed to look, and is a little bit better from a readability standpoint. But that is just another example of difference between Python and Java. Is Java doesn't care about indentation. Okay, I may delete that last part or not, and if you hear me saying that and you have no idea what I'm talking about, it's because I deleted it, and it really is not that important. Anyway, hopefully this makes some sense. We were back doing the monitor, and yeah, that's how we monitor. It includes doing things such as getting our hosts, extracting all of the body information from it. I'm not sure I went through that, but we did mapper in order to do that. So we ended up getting our hosts back, and then doing this, our ping and ping hosts. All right, I realized I goofed up and I didn't go down into get hosts. I did go down into detail of ping hosts and monitor hosts. So what I'm going to do now is I'm going to go into a little bit of get host. This will be pretty quick. As you can imagine, what I'm basically doing is I'm going to be making a request. I'm using the same HTTP library. HTTP client is my client. I'm going to create a request. The request, this should look familiar to you. I'm going at localhost /hosts, and that is the same API that we've been using for a while. I'm saying that I'm going to be expecting back application JSON, and I build it. And then what I'm going to do is I'm going to actually do the send. And I've defined my response. This is what I'm expecting as my response. Remember, it's a hash map with the key being string. That will actually be the host name for every one of these entries, and then the host. So basically, it's like a list of hosts, but it's a map of hosts. It has all the hosts, and because I've done it in this way, there's going to be an item, which is the key, which is the host name in front of it. Here's how I do my send, same as before, and I'm checking to make sure that I get a 200 response code, because it will be 200 because I'll have data. And now I need to do this mapper business, and this is what I do, where I need to declare my mapper, and then I'm going to do a read value. Now this will look like gobbledygook to you, I got to admit. It has to me in the past. I don't want you to spend too much time on it, but basically what I need to do, the way that it works with this mapper, and you may or may not run into this in other situations, what I need to do is tell it what is the data structure in which you are going to put this JSON hosts JSON data into. So we've received all of these hosts back from Quokka, and we need to translate it into objects. And you'll recall this was a lot simpler with Python, and that's true, but basically I'm creating an instance of type reference, and my type reference is going to be a hash map. Whoops, don't do that. It's going to be a hash map of string and host, and then this is helping me to create it, and these curly braces just need to be there. So basically that is helping the mapper to know how to translate JSON hosts into something called hosts. And as you can see from the stuff working, what I end up with at the end of the day is this thing called hosts, which is going to be a hash map which has host name and then host object. So there's going to be a whole sequence of these things for every one of my hosts. Just so to reiterate the point with here, you can see I have 17 of these. So when I say get host, it's going to return 17 of these. The key and for every item, the key will be the host name, and then the value will be all of this information from the line. Everything that was in hosts will be there. Okay, so that is this code right here, the details of getting the hosts from our Quokka service. Okay, so let me demonstrate to you how I actually run this. So this is my Quokka user interface. Remember, what I want to do is I want to not run the normal Python host monitor, which is written in Python, of course, and run instead my Java version of this. So right now in this screen, this is my monitors. I have all of my monitors running, except, as we'll see in just a minute, I'm not running the monitor for doing host monitoring, but I am running the others. Up here in this other screen, I'm running my Java version. So this is my Java version of what I'm actually doing for host monitoring. Now if we come over here, I'm going to stop monitoring. So I'm going to stop the monitors from running. And what I want to do now is I want to look at and show you what my run monitor script is. As you can see, what I've done here is I have commented out the line that is running host monitor. So it is actually not running my Python host monitor. Instead, up here in this screen, in this terminal window, I'm actually doing the running of the Java version. So that's what that is. And I'm going to leave this not running for the moment, and I'm going to shut this down, because what I want to do, you'll recall from the GUI, let's look at the GUI here. I have all of these items in the GUI. What I'm going to do is I'm going to come down here and I'm going to go, I'm in Mongo right now. In fact, let me get out of here so I can show you getting back into it. This is how I run Mongo. I say use, if I can spell it, quokka-db. And now I'm on quokka-db, and what we've done this some commands before, but I'm going to do db.hosts. The name of the table is hosts.drop, and I'm not going to pass it anything. And what this will do is it will delete everything from my host table. So if I come back here, I could either wait patiently for this time to expire, or I could bang the refresh host button. I've gabbed long enough that I shouldn't have to do this. And what you will see is that I now have no hosts. When I go to record hosts, I don't actually have anything there. So what I'm going to do is I'm going to come back and I'm going to start monitoring. Now remember, it's not doing host monitoring. If you have a quick eye, you'll be able to see that it's not going on there. But if I was to refresh hosts, normally I would have some hosts by now, but I don't. So what I'm going to do is I'm going to run my Java program. Now let's look at how I'm actually running it. It's very easy to run it from the debugger. So if you're familiar with PyCharm, I can just go click and run it, and it's fine. It's way more difficult to run it from the command line, and the reason has to do with the way that Java programs are run. And this may scare you off of it, but let me do a VI of run host monitor java.sh. Here's my simple command. Let me see if this actually expands it a little bit. So here's my Java. Here is some stuff about the encoding. Here is my class path, and that goes all the way down to here. What is a class path? It's the thing that says where is Java going to get the classes that it's going to be executed. Now, I actually copied this directly from IntelliJ. So you can get the command that it runs in IntelliJ. I copied that and I pasted it into here so that I would have an appropriate run command, because I couldn't figure out how to get all of my stuff included in the class path. Now what you're going to see is most of these things, well, one of these things is going to be my Java production for quokka-prime. That's the main spot where my class path is. That's basically this thing that we're looking at over here, except it's this out thing that you see over here highlighted. It's actually red. And what comes after that, all of this stuff is simply for having the ability to do JSON serialization and deserialization into and out of my Java classes. So I have a class called host, if you recall, and host looks like this. And so if I want to take JSON data and put it into host, and I want to take host data and put it into JSON, then I need some libraries to help me accomplish that. And I had to do this installation of this stuff. So it did get installed, and I need to reference it when I run it. Now, we don't have time. This is more like a couple-day class to go over all the details of running more involved and complicated Java software. There's a tool called Maven, which we tend to use, which identifies dependencies and pulls them in if necessary, and make sure that the class path is set correctly when you run it. We're not going to be going over all of that stuff. I just want us to know what it is that we're doing, what Java is like. The last thing I'll point out here, does this look familiar? This is my main class, all right? quokka.home.main. And if you see here in my main class, it's in package quokka.home, and the class is called main. And so this is what I'm actually running. I hid this from you before, and I hid it and I put it in this nice handy run host monitor.java. So let me, before I actually run this, let me go and get rid of this. And here is my host table. Now my discovery is going to happen fairly slowly, because basically I'm going to have my background discovery thread running, and in the background I'm pinging every device, or every IP address I should say. And what's happening as I go through this is all of the early IP addresses like .1, .2, .3, .4, etc. Those are timing out because they don't exist on my network. I believe that the first one is 10, and this doesn't actually show it, but I did find a couple of devices. Let me bang on this so that we can see that they got added to the database. So 192.168.10 got added, and 11 got added, and here's the host name. So my Java code has successfully discovered those devices, and it goes through here. As it goes through here, it is going to gradually pick up more and more devices. And the monitoring, when this gets around to doing monitoring, once again, it will retrieve the hosts from the database, and then it will ping all of those to see if they're alive. And as you can see, it has just updated them just about right now. You can see that's this time frame. Now my port scanning is still running over here. Remember, we looked at the monitor script that's running this, and we're still doing port scanning. It's still reading devices from the database. We talked about this before, because nothing in here had to change when I replaced this host monitor Python version with a Java version. And the downside is that I didn't figure out how to easily and simply get the MAC address. I did figure out how to get the host name, but not the MAC address. So we'll see it like this without the MAC address, unfortunately. Now you will, if you do look over here, you'll see, oh, it has run the port scanner for at least these. It hasn't done it for these two right here, but it has for the other. So that's you can see this kind of in action and how it is actually working. Hopefully that helps to shed a little bit of light on a couple of things. Number one, how I modified things so that I could use this Java monitor rather than the Python one by commenting out the running of Python monitor, and then by running the Java thing here, which we saw was a very, let's see, I don't have the VI output, unfortunately, it doesn't keep that, but you saw all the stuff that was on the class path. It was pretty involved and complicated. Anyway, that is how we run this program. All right, so let's review what we talked about in this lesson. In this lesson, we were attempting to do a real-world Java application rather than just some test code. And in doing that, what we were attempting to do was to replace the Python version of this host monitor application that contributes to our quokka-prime application and replace it with a Java version that we would build and run. And so we extolled the virtues of having this loosely coupled architecture with a RESTful API that meant that it can perfectly easily coexist with all this other stuff running, because the communication point is just this REST API, and everything else can work exactly as it was, and things would get printed out here by the user interface perfectly okay, etc. So looking at the code, we first talked about the structure and how with Java, what we tend to do is we follow convention in terms of the directory structure. This looks a little bit involved, but that's where everything lives. I called it quokka.home just because. And we built these things like main, which is our main application. And then we had a discovery thread, which we created and ran. We have a monitoring class that we instantiated, and we called its function to monitor hosts, and it sits in a loop forever and monitors hosts and adheres to the appropriate time schedule of how long it would sleep in between monitoring, etc. So we looked at all this code. We refreshed our memory that we use curly brackets. We looked at this while loop, which is similar to what we have done before. We talked about statically versus dynamically typed variables and the need to do that and to declare them exactly as they are. But we also mentioned that you can use this var keyword, and if there's enough information, in other words, in this situation with get host, we know it returns a hash map with string and host. If that information is available, then we can just say var, and Java is smart enough to infer and determine what the type of that is. And so here we see a for loop where we're going through the for loop, etc. So that is basically what we did in this lesson. Oh yeah, the last thing that we did is we talked about how we actually went about running this. I mentioned that it's very easy to run stuff from within your IDE. In my case, that's IntelliJ. Running it from the command line was a little bit more difficult, but I did mention how it was that we changed the monitor to comment out running the Python version, and I'm running, in this situation, you can see I'm running the Java application all by itself. So hopefully you know a little bit more about Java and running actual Java programs that actually do something in a real-world environment, and you're a little bit more educated about a different programming language. That would be Java. As always, I hope you have understood and benefited from this, and if you have any questions or comments, please let me know. Thanks for watching and listening.